Welcome to Time Series Visualization. My name is Justin Braaten. I'm Developer Relations Engineer on the Earth Engine team. And I'm really excited for you to be here today. This is my absolute favorite topic. And I often describe my job as largely inspiration and education for Earth Engine. And today's presentation will mostly be sort of inspiration. I've got a lot of cool graphics to show you and a couple demos, but there won't be any hands-on. I won't ask you to open a code editor or a Colab notebook. So just follow along, enjoy the GIFs. And I've tried to include as many URLs to script links as I can, so you can go back and visit slides and figure out how I've done things. So with that, let's get started. So this is our spaceship Earth. This is the Equinox from just about 2 weeks ago. And this is taken from the GOES 16 satellite. So it's above Earth at about 20,000 miles in a geosynchronous orbit. So it's tracking the same location on Earth all the time. And there is so much going on in this image. And David Byrne from the Talking Heads has this really great line: everything that happens will happen today. And I think that's so fitting for looking at imagery of Earth like this in a single day and imagining what is happening on Earth. It is so living and it's so dynamic. And it's a really exciting time to be in the geosciences with the availability of so many streaming satellite platforms. And cloud computing platforms are making them so accessible to generate these time series basically in near real time, travel back in time, if it's projected data, traveling forward in time. And so see, these are some of the things that are happening. This is the Ucayali River in Peru, and this is from a Landsat time series. I think it's about 38 years, and it is just wildly dynamic. Oxbows and bends and new stream channels. And this is data from the Tropomi sensor. So this was from some forest fires. It's an aerosol plume going over the Pacific. And we've got lots of other changes. Coastal dynamics. So we have coastal erosion on Cigar Island in India on the left. Forest change in British Columbia on the right. We have forest harvests there. You can also see surface coal mining. We have Lake Pupu in Bolivia, and you can see that it's shrinking. And opposite that, we can see irrigated fields outside of the Nile Delta. These are Landsat time series as well. Also about 38 years. And we can also travel way back in time. So this is Landsat, but it's including the MSS sensors. So we have data from the 70s. This is a 50-year time series shown in false color. What we're seeing here is the tasseled cap transformation. And we've got Mount St. Helens, the eruption. So it happened in 1980. And you can see that big swath of kind of reddish purple up here in 1980, and then the forest regrows. We can also see lots of different types of forest harvest, different types of land management. There's several agencies, federal agencies and private holdings in this area. And we can also look at modeled data. This is temperature modeled into the future, 72 hours across the United States. Forest fires. This is this is GOES 17, the Creek Fire, California 2020. And you can obviously see the smoke, but what is kind of cool here is you can also see the fire show up. So we're including shortwave infrared and mapping it to the red component of visualization. And so when it flares up, you can actually see the heat, the fire very well. Another GOES animation. This is of recent Hurricane Ian. This is over several days, maybe 5 days, shown in true color. And this is showing NDVI, sort of a surrogate for vegetation productivity. And it's shown as median monthly composite. We're compositing the same month interannually. So the whole time series from, I think it's 2020, or excuse me, 2000 to 2002 or something, up to the present. We're compositing each observation. And so we've just looked at a whole bunch of image data as GIF time series, but we can also look at table data. So what we're showing here is Santa Clara temperature, the county we're in now, for greater than 100 years. And what I've done to produce this is run reduce region over a series of images to create a feature collection, basically a table, and then plotted it in ggplot in R. And this is an example of plotting a temperature again, but this time it's through Python's Altair library, a similar process of extracting, summarizing pixels in a time series, making a table, and then plotting it. We can see this same data just in a different view. So PDSI is a drought indicator. So this is showing drought from 2003 to the present. So we can see that we've just come out of a really severe drought, but are still sort of in drought mode. And Earth Engine's got a whole bunch of helper functions that can help you generate time series charts. So the last charts that I showed are taking a feature collection, generating a CSV file, and rendering it in some other application. But in Earth Engine, there are a series of helper functions that you can take a feature collection directly and specify a few arguments, like what bands that you want to show for what region, and it will extract the time series for you. You don't have to map a reduction over it. So it's super convenient to explore data. On the back end of it, it is using Google Charts. So in this example, it's just taking an image collection. It's a MODIS image collection. There's two bands, enhanced vegetation index and normalized difference vegetation index. Those are the two bands. And it just charts the whole time series for this particular region of interest. But alternatively, you could specify multiple regions with a single band. And so instead of showing the bands as series, you get to see the different regions as series, which is nice to compare between regions across time. There's also a helper function for looking at intra-annual variability among different variables. So here we're showing the day of year as EVI and NDVI. We can also show the series by year. So in this last one, we've had to select a single year to show the day of year across the x-axis. And in here, they're included as series, but we can only show one variable at a time. So it's NDVI in this case. And we can see that 2019 had much higher NDVI than 2012 during the summer season. And we have another function here, those series by region. So we can look at this same data intra-annually, but broken up by region instead of year or by band. So that's some of the things that we can do with Earth Engine time series visualization, animations, and charts. So here's some of the tools of the trade. I want to introduce the functions that are used to generate these things that we've just seen. But it all starts with an image collection. So an image collection It's just a series of images. You could think of it as a table, really, where rows are observations, single images, and columns are properties of those images. So here I've just shown two. These are Sentinel-2 images, and a couple properties that they might have. And I think we have over 700 data sets now in the data catalog. Not all of them are image collections, but there is so much data as image collections worth exploring. Sort of anything that you're curious and interested in, is probably something in the data collection, in the data catalog that you'll find to suit the need. So talking about animations, here's the functions that you can use to generate animations. The ones in green are the most direct. The ones in orange are less direct, but you can still make graphics and animations from them. So generally what we're doing is taking this image collection, which are these series of images, and they're being rendered on Earth Engine servers as GIFs, as MP4s, as thumbnails, and also as map tile layers. And so I'll go into detail on a few of these in the next slides. And basically, when you're wanting to do an animation, there's this series of steps that is very common. And these are just sort of the basics of it, but you import an image collection, filter the collection by bounds and time, so some region that you're interested, some time period that you're interested in, and then apply some styling to it. Those images, it's just a grid of numbers, so we want to apply some color to those so it makes sense to our brains. And then we create the animation using one of these functions. So this is UI.thumbnail. Any of the UI module functions are only available in the code editor or Earth Engine apps. And so I kind of think about the UI thumbnail as mostly an apps component. But it's sort of the most convenient for a quick look at a time series because it will print to the console. So what I've shown here is a bit of code where we are importing our collection. This is a Modus collection for NDVI. I've selected the year 2018, and I'm providing some visualization parameters. The band I want to visualize is NDVI. I give a min and a max value to stretch my palette across, and the palette I've chosen is white to green, and I give it a region that I want to display in the animation. So this is basically global plus minus something on the poles. And then I give it a dimension. How big do I want this GIF to be? The projection that I want it in, and the frame rate. So I set these parameters, and then I call this function UI.thumbnail. I give it the collection, I give it the parameters, and I say, stick it in the bottom left of my app. And so we see that here. Alternatively, if you're just sort of playing around and exploring on your own, it's really convenient just to print it to the console, and that's what you see on the bottom here. And from here, if you want to save it, you just right-click, and you get an option to save as. And this is a really similar function, except that instead of it generating and rendering the animation on your screen in the code editor, what you get is a URL that you can open up in another browser tab. For instance, here I've opened it up in another browser tab. And the URL is a set of instructions to generate this GIF. And then it will display on your screen. Again, you can right-click to download. The setup is basically the same. This will look familiar from the last one. We get the collection, provide some parameters for visualization, and then we call get video thumb URL, and then we print the URL. But probably more powerful is to be able to sort of programmatically do this, show a GIF in a different application. So for instance, if you're in Python, if you're using Colab or some notebook, we don't have the UI that we have in the code editor. So what we can do is we can just download this GIF from the URL and then display it in this case, IPython's display image function will show us a downloaded image. So those were all GIFs, and there's limitations on GIFs. So the GIFs are happening with the interactive stack. So Earth Engine has two kind of processing modes, interactive and batch. Interactive is, the computations are limited to 5 minutes. And so in order for that to happen, there are pixel limitations put on the GIFs that you request. It will check to see your region and the scale and the number of frames that you have. And if there are too many pixels, it thinks probably this is going to be more than 5 minutes, so I'm going to error right away. And so a way to get around that, I really like it because it's interactive. I get to see my results immediately. I can play around with the palette and the min and the max and the stretches and blending and all of this and get a response right away. And I generally do that in development, sort of prototype mode. And once I'm really happy with what I've got, maybe on a limited set of frames, then I want to export it as a more polished format. So we can export to Drive. We can export that animation to Drive, and we get an MP4. This can take a little bit longer to export. There's some overhead to set up the export. And it gets tasked in the batch stack queue. So if you have other things running, you might have to wait for the other process to finish first. But in the end, you get a much nicer, sort of professional-looking animation, which can be, I don't think I've hit the limit of it, but you can have very large animations with MP4. So the setup for this is basically the same, the collection, some visualization parameters. In the functions we ran previously, we could just provide the visualization parameters directly to the function that's going to render the animation. But to Drive, we don't have that option. So we have to style the images by mapping a function over it. So we run, for every image that we have in our collection, we call this visualize function, which is actually what's happening behind the scenes in those other functions. It's just that Earth Engine has made it convenient so you don't have to map this visualization function. But for going to Drive as MP4, we do have to do that sort of manually. We give it some parameters where we want to put it in our Drive folder. These similar things about the region and the dimensions. And we can do a similar thing, but export it to cloud storage instead of Google Drive. Setup's really similar, except now we're giving our bucket name. And so it takes a little bit of setup to do this. So if you're running to Drive, it will create a folder for you. If you are going to cloud storage, you need to create a bucket that will hold this MP4. So it takes a little bit more setup to do this. And then it will just end up in that bucket that you've specified. And so here we have a slightly different format. Now we're getting into the ones that aren't sort of a direct animation, but they are outputs that you could use in an animation. So this one is EE Image Collection Film Strip. So it takes all of your frames from your image collection and concatenates them all into one giant image. And so this is that same animation we've been looking at, NDVI with Modis. They're just now all the frames are concatenated to one another. And what you get is a URL again. So this is like get thumbnail URL, except that it's the film strip. So we can't view this in the UI, in the code editor. And on its own, it might not be that useful. I've occasionally used it to quickly look through a collection to look for errors or things that look funny to me, and then try to count and identify what number that frame is and maybe filter it out. But one cool thing that you can do with this is chop it up. So it's a single request. So instead of, we're in the Colab notebook now, we're in Python, and one thing I like to do is add annotations. So in the code editor, there's not a supported function for adding. Oh, question, let's take one.
It's less of the question, but I also thought it wasn't useful until I really, really needed that one.
Oh, the film strip?
Yes, so I can give you some example, but essentially, if you want to pull some images and have web application built where you can go back and forth or compare different images, this is the fastest way because you do one call to the API and get all the film strips instead of like firing separate for the images. And yeah, so, and then you can easily in web app chop it into the smaller images. And that's what we were also using like in Restore in our applications. And it's pretty cool film strip function, which I thought was useless until I really, really needed it. And yeah.
I'm happy to hear it. Thanks for sharing. Yeah, so that's maybe something similar where I've done is wanting to annotate frames. We don't have a function to do it. People have written some modules that can help you do that. But in any case, here I'm showing one where we've added some annotations for the date. And as Olga said, it's nice you can just do a single request to get all these frames. And then if you know how many frames you have and the length of the image, you can just chop it up using the pill Python package, and then annotate it or do all kinds of other things that you would like to do with the pill package, and then put it into FFmpeg or something similar to generate the animation. This is also limited to pixel size. So again, this is getting something sort of on the fly. So it's using the interactive stack. So again, here you are limited to the number of pixels that you can request. Alternatively, you'll get an error saying too many pixels. Another thing that you can do is export map tiles to cloud storage. And this is really cool for apps. So what we're seeing here is an air pollution plume. It's like going backward in time. So what you see there is air pollution, and then where it ends up eventually at a point over time. And so this is like hundreds of frames, and each of the frames has been stylized as map tiles and then exported to cloud storage, then imported back into this app. And because they are coming from cloud storage, they render super fast. And so you can set up in your app a function to play this animation, and as it's playing, it is turning off the visibility alternately of all of the layers, sort of simulating an animation. And we also have this option to, this isn't animated, of course, but you can still explore the time series just by looking at a series of thumbnails. And so here what I've done, this is in the code editor, and I've just expanded a panel throughout the whole screen, and I've done a for loop to just add image frames as thumbnails. And this is actually kind of nice. Sometimes you lose track of the history when you're looking at an animation, but here it's all for you to see in one screen. So I've shown you now the tools to get animations and visualizations through time from images. Let's talk a little bit about styling. If you were in my presentation yesterday on map styling, this is the same set of slides. But basically, I think the point here is that in all of these formats, it's PNG or JPEG images that we're viewing. And so if you have data that are 16-bit or float, it needs to be compressed. It needs to fit into these specs of PNG or JPEG. And so we have this function, ee.image.visualize, that will do that for you. And as I said, some of the functions will run this without you even knowing about it. But behind the scenes, this is what's happening. You have to select the bands that you'd like to visualize, the min and the max, so we can stretch a color palette across those values, and then optionally give it a palette to provide color. Otherwise, you get grayscale or a mix of RGB if you're doing 3-band. And then also you could add opacity, which is really cool, and I'll show you some things that you can do with opacity shortly. So this is just an example of taking elevation. In this case, the range of elevation is 200 to 2,500. It's outside the 8-bit range, which maxes out at 255. So we've selected two values that sort of represent this region well as mins and maxes. And the visualize function is clamping it and rescaling it to 0 to 255, and then laying this color palette over it. So that's the default, is to get grayscale if you're looking at a single band, but you could also add a palette. So if you got a color palette you really like, I like these 3 colors, and so I provide them as an argument in the palette parameter when I'm calling image.visualize, and it'll lay this nice color palette linearly over my data range, and I get a really cool figure like this. It looks like lightning. I think it's really neat. And this is the code that is doing this. So I've loaded up my digital elevation model. I'm calling visualize on it with a set of parameters. The only difference here is in this top one, it's just the default grayscale. The bottom one, I'm providing the palette. These are just hex codes for colors. We could also do styling with categorical data. So previously that was more continuous. And what's important here is that if you're going to work with classified data, that the classes be in sequential order, preferably starting at 0. And then you set your min and your max to whatever the min and the max of your series happens to be in sequential order. And then provide a color for each of your classes. So we have 9 classes here, starting with 0, ending at 8. So since there's 9 classes in our data, we provide 9 colors. This is dynamic world data. We can also visualize RGB. So if you provide 3 bands to the band palette, it will do RGB color mixing. So this is a Sentinel-2 image. And it happens to be false color, so you can set any band that you like to red, green, or blue, and it will mix those so you can sort of have a superpower and see outside of the visible spectrum what things look like in SWIR, for instance, or near infrared. And this is the code for RGB. Again, really similar, image.visualize, except here we are providing 3 bands instead of 1. And in all the previous examples, the min and the max that we're stretching our color on has been a constant, but you can also specify band-specific values for min and max. And so this is showing you how you map this function over a collection. So image.visualize, it's working on an image object, so only one image at a time visualize can happen on. So you have to, if you have an image collection that you want to animate, you need to map this visualize function over the collection. So that's what's happening down here. And I often like to do this anyway. If you're using UI.thumbnail, you don't have to map visualize over your collection. But you get a lot more control over what you can do in terms of adding different layers to each other if you map your function, because you can add extra things inside of it. So it's a good habit, I think, to get into, to just run this despite there being helpers that you don't have to use to do this. Yeah, so for instance, one of the cool things that you can do if you're mapping visualization over your collection is to include another layer. And so here what we have is a hillshade from a digital elevation model, and we can set that sort of on our palette, and then we can take a frame from the NDVI image collection and make it slightly opaque and lay it on top of the hillshade layer, and you'll see the hillshade layer show through because the top layer NDVI we've set to partially transparent using this opacity parameter, which is the first time that we're seeing this in our examples. So this is one of the optional parameters for visualize. So in my mapping function to style this, I'm taking my collection of modus NDVI, and for each image, I am taking my hillshade layer and I am blending it with the modus NDVI visualized, as such here. And the way this works is it takes hillshade, whatever is first, that's on the bottom of your palette, and then whatever comes next lays on top of it. And so you can do some cool things. This is the Ucayali River again in Peru, but shown using the global surface water data set. And it looks pretty cool, but it's a little bit noisy, and it's hard to remember the history. What did 1984 look like compared to 2018? It's a little bit hard to remember. But if you add some opacity overlays when you are mapping visualization over the collection, you can retain some of the history. So now you can see that there is like a fading sort of ghost history, which really smooths out the animation and gives you a better sense for the history. So this is adding opacity layers. But you could also, at each frame, use a different color, for instance, to color your data. So this is showing each year with a different color overlaid on top of each other, which is another neat feature. Another thing you can do with opacity is transitions. So this is 3 different images, but they have some fading from one to the other using opacity. And the scripts to run these are a little bit, sort of in depth. It's a hobby and interest of mine to make weird collections. But go to these links at the bottom if you're interested in how I'm doing this, and you can find the code for doing it. And generally, I try to write good code comments. This is wind particle tracing. So if you were to drop, randomly some particles at a given point in time and let the wind take them, this is what you would see. And it's, sort of tracing through time and slowly, removing the history. And this is also, again, just adding a slight opacity layer to each new frame in the collection. And that's also how this animation was created, by adding opacity iteratively. I guess it's not iteratively, but in a mapped function. And you can also do things like shift each frame. So when I'm in this mapped function, at each frame, I move it a little bit by calling image.translate and give it some x and y offset to shift the position of the frame. So what we see here is some GOES data showing a windstorm, and it's tracking it, as it moves south through like Colorado and into Texas. And it's also showing an overlay of states, which is something that you can do with Blend. So let's do a quick demo. And what I wanted to do was just sort of walk through my thought process a little bit as I'm making these animations. So this is a Colab notebook. Generally, oh, question? Yes, thank you. Is that okay? Usually I like to work in the code editor just because of sort of familiarity and the integration with being able to show the animation right in the console quickly. But for showing a process, it's nice to be able to walk through code cells in Colab. So I'm authenticating to Earth Engine servers. It recognizes me, it says you're good to go. I'm going to load up a way to display images. So now I'm going to get a collection. We're going to work with this same Modis NDVI that we've been working with for familiarity. We're getting the year 2021. And I want to make a whole time series. I'm like curious about what the interannual variability is for NDVI. And yeah, I could pick any year. I'm going to pick 1 year to see what it looks like. I'm sort of assuming that I don't know a lot about this data set. I haven't worked with it. So I just want to see what it looks like. I load it up. And I'm just going to preview it, like, what are we working with here? And so I get some strange results. I can see things are moving. The animation has worked. It's got frames, but it's black and white. And so I think the problem here probably is that the data are outside the range of 8-bit data. So one way you could tell is what you should be setting your min and your max at is to get some statistics. So what we're going to do here is run a reducer over a region of the image. I'm picking an image from July, just to get an idea of what min and max should be. So if I run that, it's getting the percentile, the first and the 99th percentile of the world at a really large scale. It's 10,000 meters, 10,000 meter pixels. And that's just sort of a rough guess. We're just trying to get close to something that will look good to get our data into a range that we can visualize. So we can see that, let's just estimate that the min should be 0 for NDVI and the max should be 9,000. So we can tell that these data have been scaled outside of their typical float range. And so now I'm going to set 0 and 900 as my min and my max. Previously, I didn't set that. I didn't know what they were. But now I know, so we've set that. Ah, great. Okay, so now we get some variability. It makes a little more sense. I can sort of see what I'm looking at, but grayscale's tough to interpret. So I want to add a more self-evident color palette to this. So it's NDVI, it's about vegetation, so I'm going to do white to green. So I add this palette parameter. All right, so this is now a little bit easier to understand. I can see where it's dark green. That makes sense to me from what I know about the world where vegetation should be. But I don't like this projection very much. It looks a little funky to me. So now I'm going to go in and I'm going to set the projection. So by default, it's just whatever the projection of the data are in the catalog. So I'm going to do this world equidistant cylindrical as a projection. So I just sent my coordinate reference system, and all the other parameters remain the same. Okay, so now this looks really familiar to me. This is, it's making me a little bit happier. And there's just so many things going on here. There's lots of stories to tell, and it's kind of a cool animation, but it could be cooler if we just focus in on an area instead of it being so busy. So I think that looking at this, Africa looks really neat. And so what I'm going to do is set my region. Instead of it being more global, I'm going to focus in on Africa. And up to this point, I've been setting the dimension really small, and this is helpful. Your request comes back so much faster if it's a small dimension, and if you're just kind of prototyping, you might as well just get a quick response. All right, so this looks good. It's something that we can kind of talk about and interpret. We see that vegetation is sort of moving up and down, the productivity changing with the seasons, and this is pretty cool. And so I'm liking this. I'm going to make it a little bit bigger at this point. So I have changed my dimensions here to 500. Everything else stays the same. I just want to look at it a little bit closer. So now we get a good look. But it's kind of noisy. Do you notice, we get kind of this white mixed in with the dark green. And remember at this point, we're only looking at a single year's worth of data. I think it's 16-day composites. And so, there was clouds that are getting mixed in here, or clouds that had been masked out and filled in with other pixels from a different period of time. anyway, if we're thinking about a story about interannual variability, this just looks a little bit messy, and it's only representing 1 year. So what we could do is do some statistic across time for each of these time slices, each of these 16-day composites. MODIS has data go back to, I think, 2000, so we have about 20-ish observations that we can do some statistic on per pixel. And hopefully, if we were to do that, we would get rid of some of this noise. So, I'm talking ahead of myself here. I also wanted to see the frame rate increase. So I've upped it here, and I've included frame rate now. Previously, it was just a default. Now it's 12. It's just, showing it a little bit faster, maybe a little bit more apparent and obvious how productivity is changing. I got way out of myself. This one now, we've been looking at this palette of white and green, and that looks okay, but it's not great. So we could add a really specific palette here. Instead of just white to green interpolation, we are specifying many colors. And this looks really cool. I like this one a lot. But still, we have this problem of the noise. So what I'm going to do is do a join. I'm going to add. So I want to get little collections of all of the 16-day composites through time, and the easiest way to do that is with a join. So what I have to do is make a property that is the same, that is going to be the same through time, and what I can do is use the day of year. So for each year in MODIS, the same composite is given the same day of year in the metadata. So I can get the day of year from the image metadata. This is a function here to add the day of year to each image. I map it over the collection. So now every image in this collection has a day of year property, and each year has one observation that is going to match all of the other years. And so I do this join to find those matching day of years across years. Oh, I need to run this cell. And I'm doing a save all join here, and what this does is taking a distinct DOI collection. So from the year 2021, I'm pulling out all of those images. They all have a unique day of year. And I'm going to join my full collection to this distinct day of year collection. And so for each distinct day in 2021, there's going to be an image property that is the list of all other images in my collection that match that day of year. And so then what I can do is map over all the images in 2021, pull out the property that is the list of all the images that match that DOI. Yeah, so here I'm showing that as an example. Once you've done this join, it makes this DOI matches property. And if I print that, you can see that these are all of the images through time that have the same day of year. So these have all been assigned January 1st. There's an image for 21, 2002, 2003, etc. And we're going to composite all of those images per pixel per year. And that's what we're doing here. So now we have this median collection. And we just provide it in our thumbnail URL that we're going to display. And it'll take a little bit longer to render because it has to do this median computation. But now you can see that we've gotten rid of a lot of the noise by using a statistic. Yeah, so it's looking really smooth now. We're looking good. But it looks kind of flat. It could be more interesting if we added some hill shade, I think. So I'm bringing in a digital elevation model. I'm multiplying it by 50 so I can exaggerate the elevation and get a little bit sharper hill shade. So I get this hill shade layer. And here I am doing this blend again, where I lay down my hillshade, I blend on each image in my collection. That's NDVI. It's got some opacity. Each image is going to have 0.7 for opacity. I map that over my collection, and then when I render it, this will take longer still because there's just more computation. But now we get some hillshade, and this looks like a really nice animation. So that's just sort of the thought process that I go through. If it's a new data set for me, generally this is how I sort of work through it, but it's often in the code editor. So we've talked a lot about animations, but you can also, of course, be visualizing time series data with charts. And I won't go into as much detail here, but just wanted to show you, make sure that you visit the docs to read about these functions that we have to help you visualize time series very quickly. But then I also wanted to show you a pretty easy way to get data out of Earth Engine and into some other platform to show a time series in other charting tools. So I'm going to go back to Colab again. I have to do this dance with auth again. And then I import some other packages. We've got pandas for a data frame, Altair for plotting, and I actually don't think that we use NumPy in this one. And then we have 2 packages to help us make URL requests. So what I want to show in this is PDSI, sort of an indicator of drought over time. And so I'm going to do from today backward 20 years is my time range. I take my PDSI image collection, filter to that time range, pull out the PDSI band, and then I want to get the statistics over an ecoregion. So I've selected the Sierra Nevada ecoregion. So we're going to look at a time series of PDSI for Sierra Nevada. And I need a reducing function. So I've got this image collection. There's lots of images. At each image, I need to compute the reduction. I'm going to use the mean. And so I need to map a function, the reduce function, over this collection. So I define this reducing function that will do that. It's going to get the mean. I'm using kind of a large scale here just so it's quick at 5,000 meters. I've provided my area of interest, Sierra Nevada. And then it will produce the statistic. I create a feature which has the shape of my area of interest, the Sierra Nevada. I give it the properties of my statistic, whatever the region reduction happened to be, and then I'm going to set the date as this format. So each image will have this run on it. I'll get a feature out of it. I'll have a feature collection. Each feature will have the statistic, the region, and it will have the date. So I'll run that. And what you can do, so now I've got this table, and it's sitting on Earth Engine servers. It doesn't actually exist yet. There's just instructions. This is what you should do. And what I can do to get it client side is get download URL. If you call that on a feature collection, and you specify the file type as CSV, which I also think is the default, you'll just get all of the properties. You'll get a table of your feature collection. So as many features as there are will be rows in the table. As many properties as you include. I've got a selector here just to select properties by name. I don't want to include the geometry, so I'm doing properties by name. And then so I'll have columns for all of these property names. So here I'm running this. I've got a URL. And I've got this function here to have Python download this URL and read it into pandas. So I'm going to create that or define that function. And here is where it's actually going to grab that data from the servers. All right, and if we print this, we can preview the table. So this is showing us that we have the index, whatever image this is coming from. We have the date and the PDSI, mean for the ecoregion of interest. And we have that for 1,459 observations in time. And we can use Altair to show time across the x-axis and PDSI on the y-axis. And Altair just has a beautiful charting library with so many options, highly customizable, and being able to just get the URL and import it as a table is super slick. You can even do it in R. So I started out using ggplot a lot and still really like it. And you could do this same routine with R. So I'm in Colab right now. I do a few things so that I can run R. And I won't show a chart here with R, but I'll just show you that we can download the data. So we have a Tibble format here, if you're familiar with R. And it's the same thing that we saw with the pandas data frame, where we have the image ID, the date, and the PDSI for all of our 1,400-ish observations. That's that. Thanks a lot. And I'll take any questions if you have them. Sure.
Hey, thank you. The animations aspect with the GIFs, I'm curious, are there any static data sets in Earth Engine or any ways to put just regular base maps with political boundaries underneath some of those animations, just so you can view like a regular map with maybe air quality data or vegetation data on top of it?
Not really.
Okay. Asked and answered. I wondered if maybe I could like import an asset maybe that's a base map image and then blend it with that blend function or something.
Yes.
Oh, you can? Okay.
You could. I've wanted to do this as well, and you can use political boundaries. So we have feature collections, essentially like a shape file, with the boundaries of countries or states, but nothing like map tile layers that, but you could probably for smaller regions, because they're kind of high resolution. You could import your own as a geotiff and then blend that.
Okay, perfect. Thank you.
Yeah.
Thank you. So I had a question. So just like we did for image collection, the video, the GIF, can we do that for a feature collection, like every day?
Yes. But what happens is that you have to paint the feature collection onto an image and then style that image. So it's a little bit indirect.
Okay, so it's not similar approach. We have to make it into an image collection and then use it.
Yes.
Okay.
Unfortunately, there is, I showed it yesterday, I don't know if I can get to it very quickly, but look up feature views. I guess that's not, you can't really animate that though. Yeah, the best thing to do for GIF animations is, the only thing that you can do is paint them onto an image and then animate the image collection.
Okay, yeah, thank you.
Yeah.
Beautiful presentation, Justin. Beautiful visuals. I think that yesterday when we kicked off the event, I learned, academia, science has a gap with policy, and I feel like being able to do this work can help with that gap potentially. Just wanted to ask you open-endedly, what were your thoughts on that specifically?
Yeah, I mean, David Attenborough with like the Planet series is like such a huge inspiration, and I think it's so affecting, at least personally, to be able to see our world with my eyes, to be able to see places I've not seen before, to gain some kind of empathy, and in some way, I want work with animations to be able to do something similar, to be able to tell stories. So much of what scientists do is quantitative and hard for the general public to relate to. The quantitative part is really important for policy and understanding how things work on Earth, but to sort of have effect, you need to reach people on a different level, I think. And I think animations, and particularly animations, and to some degree time series charts, can really help with that. And sometimes I feel a little bit limited with the tools that we have to make GIFs and MP4s, and would really love to have more connection with Google Earth. That's such a powerful potential for a digital twin. The interaction with it, it's so engaging. And through Voyager stories, Googlers have been able to put together really great immersive stories. And I think it would be awesome, if there was more of that available for people to do.
So, thank you again so much for the wonderful presentation. There's some graphics up there are definitely wallpaper worthy, for sure.
Thank you.
So, on the point of actually making things accessible for policymakers as well, are there any ways you can make animations like these perhaps a bit more, say, interactive? Like maybe you can use a slider to show like, oh, and maybe you could look at this frame or like maybe like this particular area. So as like maybe if you want to hone in on like a specific time period, and then kind of look through those.
Totally. So the air pollution one that I showed, there's it's in the GUI, and there's a slider actually. So you can either press play, kind of fast forward one at a time, or you can use the slider to go to a certain frame. Also, I wonder if I can show it really quickly. I have a neat example of being able to create an animation on the fly. With a GUI. So you could, this is an Earth Engine app. You could just send the URL to anybody. They can access it. They don't have to have Earth Engine credentials or any kind of coding experience. And they can just draw a region, do a little bit of slider work to set some parameters, and then they get an animation like that. So you can definitely include animations in apps and make it more accessible.
That's awesome. Thank you so much.
Yeah.
We're going to start over here.
Hey, so this may be more of a feature request, but is there any plans about having sort of like animated graphs that could accompany an animated GIF?
I'm looking at Tony. I don't know if I don't. I feel like these are things I shouldn't talk about, or I don't know, I guess is the answer.
I mean, if you're in Colab, you can use all kinds of other controls, right? Like you were using Altair.
Altair, yeah.
And so there's other controls too where you can animate the data. Like you have the underlying data, and the control itself can can provide you animation. In the Earth Engine apps, you would have to do it in JavaScript, and so you're a little bit more limited.
Yeah, I mean, I think functionally right now in Earth Engine, it's not possible to do it in the code editor. Not saying that at some point a feature couldn't be added, but certainly, being able to just download a feature collection quickly and bring it to some other platform. Yeah, I would personally really like to be able to have a different charting library in the code editor that would provide more options. We could team up our feature request +2.
Also, since I have the mic, feature views Justin mentioned, and that's a brand new feature of Earth Engine. And so check it out. Like, it allows you to style feature collections in a very flexible way, and it's so fast that you can actually change the style and animate it, or hook up a slider to the style of the feature collection, and it's so fast that the rendering looks really good.
Oh. Yeah, so this is comparing feature view on the left feature collection on the left, feature view on the right. Yeah, so it just loads really fast. And like the air quality, air pollution plume, you could animate layers this way in the code editor. Yeah, and so what's happening then is you got this whole stack of layers, and initially they're all turned off, the visibility. It's a property of image layers. And then it just cycles through turning them on using a timer in JavaScript. On and off.
Excuse me, sorry, whoa, that's loud. Real quick follow-up, since we're talking about feature views. Is there a way to export a feature view as a map of any sort, or does it just live in Earth Engine?
Just lives in Earth Engine currently.
Okay. Third feature request.
All right. Well, thanks all.